All right. Hello, everyone. Hope you're all doing well, and thanks for tuning in to learn more about testing. We don't have too much time, so I'm just going to jump right into it. This topic is very vast, and we're only going to be able to scratch the surface of what's possible. And so I'm going to kind of use this as an opportunity to provide a buffet of different topics that you should be thinking about. So when you leave, you know exactly where to go to find resources and know how to go about doing more in-depth research on the parts that matter to you the most. So with that said, let's go ahead and jump right into it. Cool. So the number one question that comes up when people are thinking about testing is this question of, what types of tests should I be writing? There are all sorts of types of tests. People have kind of learned testing in all sorts of different scenarios. So they just kind of pick up what they know, and that's kind of the way things stay. But right now we're going to have a chance to kind of take a high level look at the different layers of our application and how different types of tests apply to those layers. And this is going to give us a good construct to think about testing. And I know, there has been many abstractions about the types of tests we should write that have been evangelized, and they can be very useful. I'm not going to try to add another abstraction to that, but I just want you to all have a nice mental model of what you can accomplish with testing. So let's get into it. So let's break apart our application into these very high level layers. We can break it apart into these three. One can be the UI layer. So that's the interface our users interact with. And then we have the client logic layer. So this is all the internal business logic, but still all packed in our front end applications. And then we have the kind of the final layer here, which again, it's a very high level look. This is what I call the service layer, or the API layer. But this is where the front end, interfaces with the network, and that is the service layer. So this is the kind of the three high level layers of our application. Now let's put an overlay over these three layers to see how testing applies to all. Cool. So this demonstrates, the impact each type of test can have at each individual layer of an application stack. From the very top, let's start from there, is end-to-end testing. As its name implies, is that it touches everything from start to finish. It will go through the UI layer, the client logic layer, and the service layer. It's going to touch everything. And it's typically the type of test that is going to give you the most bang for your buck. But also there are all sorts of challenges with end-to-end tests because you have to provision, and have all these layers be in a good testable state. Another interesting test here, and I'm not going in exact order, is component testing. Component testing is the other type of tests that we all like to write, especially as fans of Nuxt. And component testing can get us really far, right? They can test a good chunk of our front end, and it can give us a tremendous amount of confidence. And so these are the two types of tests that we're probably going to be focusing on, and specifically more component testing, because a lot of people already know Cypress, for its end-to-end testing capabilities. Component testing is one of the things we'll focus on today, and we'll also touch on visual regression testing as well. And visual regression testing is really there to just, give us some confidence at the presentational layer, and we'll get into that. And then we also have the integration type of tests, which could be perceived in all sorts of different ways. For the sake of our discussion for today is, you could use an integration test to effectively just test your front end, and the back end could be mocked away. And this is useful because sometimes the API may not be ready. The back end might be being developed at a different pace than the front end. So you might need to actually mock things out, apply data fixtures to simulate what the API contract could look like. So you can keep iterating on the front end. So integration tests can be useful in that manner. And then we also have good old-fashioned API tests, which I think are pretty self-explanatory, and that they can give us a lot of confidence when you're just working on the backend side. And then good old-fashioned unit tests can be applied, at will, at these individual distinct levels, and they don't go through multiple layers. So take a snapshot of this in your mind and keep this next time you're thinking about the different types of tests you would like to write. And with that said, let's go on to the next thing, which is the thing to keep in mind is that, as we kind of mentioned, is that every type of test has its use cases, right? It's not that one test is better than the other, or one is less useful, one is more useful. Testing and its application is highly dependent on your particular scenario, the type of app you're writing, the resources you have, your team's skill set, your team size, maybe the company's resources that you have. All sorts of things will vary your testing strategy. And of course, it helps to sometimes talk about the idealistic version of that so we can all strive towards the better thing. But a good takeaway here is that, and this maps back to that every type of testing has its distinct use case. Component tests give us a lot of confidence, but they also help support component-driven development, which is the way a lot of us write, front-end apps now. It's giving us validation and confidence along the way as we're iterating on the application, as multiple people on the team are integrating, their components and their code into the larger code base. So it's helping us along the way as the final thing is being built, and as we're constructing the final thing and composing the final experience. End-to-end tests come in and enter the game and really help us validate the full user journey that we want. So you shouldn't think about it in terms of, oh, well, I have end-to-end tests, so I don't need component tests, and I have end-to-end tests, or I had the other way around, which is I have component tests and I don't need end-to-end tests. They all have their place. So one takeaway here is that, as you're developing your application and you're creating components, accompany it with a component test that validates all the state permutations of that given component. And then once you finally got it all together, end-to-end tests are really going to be there to help validate that final user journey. And you're generally going to have less end-to-end tests and component tests, but they're going to be that polish that's going to give you maximum confidence. So component testing is a new type of testing that Cypress is taking on, as you may all know. That Cypress now being pretty prevalent in the Vue and Nuxt community. It's primarily known for end-to-end type testing, but we're now taking on component tests, as you may have already heard. And so to talk about it, let's take a step back and talk about what we exactly mean by component testing for the folks that are have not really done that type of testing. It's effectively testing a component in isolation, right? It is not existing while it's under test. It does not exist alongside of the rest of the application. And the way that's been typically done with the existing tooling is that you take the component and you mount it in a virtual DOM or emulated DOM environment. But at Cypress, we think we can do better and provide a much better developer experience. So there's kind of like three primary issues that I would consider, and there could be more, of course, are, I think, kind of top issues when it comes to component testing and its power to enable component-driven development. The first thing is just confidence, which is the ultimate thing that testing is supposed to give you. When you're testing components in a non-realistic environment, aka virtualized DOM, JS DOM, things like that, you're not testing that thing in the same scenario your users will be using that component. It is, none of your users are using JS DOM to load your app. So there is that mitigation of confidence there. There's also the debugging experience, which again goes back to component-driven development, is that you're not getting this ability to introspect into the visual nature of components if the component tests you've been writing are kind of running in a very, just within the terminal, right? It's all a black box, it's all headless, and you don't really get good introspection into the visual nature of components. And then that kind of mitigates the development experience that you have, because now you don't get to see the full extent of your changes as you're iterating on that component. So it's kind of these three drivers that are motivating us to do better here. So as I mentioned, that we have a new approach to component testing that's being built out in Cypress. We now have a fantastic team dedicated to just this type of testing. It's currently been out in a beta style format, and you can start using it today. And we'll take a quick glance at it right now. And our approach here is that, as I've been talking about virtualized DOMs, is that we're not going to use virtualized DOMs. We're going to use a real browser DOM, which is how your users are going to be using, your components. And instead of putting it in JS DOM, for example, we'll mount your components in isolation in a real browser environment. And the thing that changes here is that when you were writing normal Cypress tests and you were trying to open up Cypress, you would run Cypress open. But if you go download Cypress right now and you want to try component testing, you just have to run OpenCT to get the experimental component testing test runner experience. So how does that look like? And again, this is all the rough versions of it, and the team is hard at work on completely revamping this and providing a really great experience here. And let me show that to you. So this is an example of a spec file that is testing a component here. And if you use Cypress, this is very similar to the current Cypress experience. But the addition to the UI here is the fact that now on the left-hand side, you get to just select which components you want to test. You have a dedicated spec file for each component. And when you load this experience, it just looks like this. You select the spec that you want, and then you get that good old-fashioned Cypress command log and test runner experience, where you get to see your tests execute side by side, your application. You get to see all the assertions and all the actions that took place. You get to introspect everything. You have access to dev tools, so on and so forth. And the difference here is in the way you would write end-to-end tests and component tests is that with end-to-end tests, you would have to visit a URL, right? For example, the login page of your application to authenticate and get started with, executing some commands there. But with component tests, you don't need to visit a URL, right? You can use a mount function that will provide through various modules. So, for example, there's one for Vue components, which is a module at Cypress/Vue, which gives you a mount function, and you can import in your Vue components, pass it into that mount function, and then you're on your merry way to write tests. And so this is, again, beta, something that the team's working hard on, and check out the docs, the current docs for it to get started. Now, in the interest of time, I'm going to keep moving faster here. The next thing is when you've kind of picked what kind of tests you want to write and you're writing them, then the next question is, hey, am I writing enough tests? Am I over testing or under testing? And what am I actually done with testing? It's that age-old question. Now, the thing is, one solution to this question is code coverage. And code coverage, if you're not familiar, is effectively the practice of figuring out how many lines or which lines of code were covered, were touched effectively and executed by the interactions with your application. So if I go and visit the login page of your app and I interact with it, which lines of code did I interact with? And let's keep track of that, and let's create a report from that. And that gives us a high level look at, which parts of the code got executed based on a certain set of interactions. But the thing is, code coverage is a controversial practice when it comes to testing, because, code coverage is not the silver bullet solution. It is a helping hand, but it is not a definitive indicator that you have proper coverage. And by proper coverage, I mean, it's not, code coverage itself is not important. It matters if you have properly covered the features that you've implemented and the user journey, which are more of a meta concept than the very discrete concept of, hey, which lines of code were executed in my application. So keep this in mind, that code coverage can help. It's a guide, but it's not a definitive indicator. Let's go to the next one. And code coverage, it's a big concept in and of itself. And we have a nice guide on the Cypress docs about this, which you can visit. And we also have a dedicated Cypress code coverage plugin, which helps get you up and running with getting code coverage reports for your applications. Cool. Let's go to the next thing. That's responsive testing. And this is also a great example of why code coverage, it may not be a great indicator of a foolproof coverage. And the reason for that is because functionally your app may be exactly the same. And it doesn't matter if you change the viewport size, if you're looking at it from an iPhone viewport or an iPad viewport, to check the responsive nature of it. So to get additional confidence, responsive testing is something you do want to adopt because it's important to do so. And if doing it in Cypress is very easy because you can just change the viewport size on the fly. There's a couple different ways to do this. Cypress ships with a nifty command called viewport that allows you to set the length and width of the viewport or pass in presets like, hey, I want to test an iPhone 6 or something like that. And you can also pass it in as like an environment and a config as well. But again, the good thing about responsive testing is that you can reuse the same test code that you have for maybe your default viewport size, maybe the desktop environment. But you can just execute those tests by just configuring a different viewport. So it's not like a whole bunch of additional work, typically speaking, and it can be really helpful. The next layer of testing you can do here is visual testing. And this is, again, another type of, it's another example of why, code coverage is not a full indicator of coverage, because when things are changing visually in your app, that might not trigger a different type of test code execution, right? Your button could just be, 20 pixels off, or a completely different color, or or some other visual aspect of your app might not have loaded properly, but that might not come up in a functional way. So we can't really map it back to a specific line of code exactly. Functional and logic tests give us a good amount of confidence, but we also need to assert the visual nature of our app to gain full confidence. And that's where visual testing comes to place. And I think to get a comprehensive testing strategy, you should definitely include visual tests. And to get started with visual testing, there's all sorts of ways you can do this with Cypress. There's many open source plugins already available that you can tap into. We have another great guide on our docs that kind of explain it all. There's also a plethora of third-party services that can help with visual testing that have created plugins for Cypress. So you can do that right there. And here's like an example of you exercising a command that can do visual snapshots for you. So all you have to do is get your application in the right state that you want. For example, we're testing a to-do application here. We are visiting the page. We are inputting to-do items. We're asserting we've done that functionally speaking, but then we can also run a visual snapshot command via these plugins, and they can just take a snapshot of our application at that point in time, and that snapshot will serve as a point of comparison when we're trying to integrate in our code. So definitely check out the visual testing guide. There's going to be plenty of information there for you to dive into. The next thing we'll dive into is, once you've really figured out the types of tests you want to write, you got some code coverage going that's helping you guide if you're over testing or under testing, you're fully able to validate the responsive and visual natures of your app, and you're running everything now in CI and you're all happy, then you're going to be battling the next thing, which is flaky tests. And let's kind of elaborate what we mean by flaky tests. For example, you have a test, test A here, you run it, it passes, it goes green. And then you change nothing. You change nothing about the code. You change nothing about the application, nothing about the environment. You run that test again, and then now it fails. So in this scenario, test A is considered to be flaky because it yielded a different result with the same inputs. And so, flaky tests do not provide deterministic results, and and then they'll just reduce our confidence in our tests. And so when it comes to how Cypress deals with flake, well, the good thing is that Cypress ships with and was really built and architected with flake resistance in mind. And of course, this is not a foolproof way of mitigating flake, but it does resist a lot of scenarios and has abstracted away a lot of that complexity for users. For example, when you are making assertions, Cypress automatically retries those assertions for a configurable amount of time and waits for those assertions to come to life within the DOM. And also, these things happen when we are trying to grab things from the DOM or interact with elements in the DOM as well. So Cypress automatically waits for an existence of an element, of its visibility, and also checks if it's actionable as well. These are things that Cypress has completely abstracted away and have been very common causes of flaky tests. So we got rid of those, and there's another aspect of the Cypress API and architecture that minimizes flaky tests, which is that Cypress is more of a declarative than imperative API. And what that means is when you are composing your tests like this, Cypress has not executed them imperatively. It's actually looking at each chain of commands here, and it is execute them in that exact order by creating a deterministic queue in the backend. So what you see is what you get in terms of what gets executed in the browser when you're using Cypress. Now, that's all part of the API and Cypress's core architecture, and we've recently added additional functionality to help mitigate flake. And one way to do that is test retries. Test retries is just one way of managing flake in your pipelines. And what does that look like? What does that mean? Well, let's go back to the example we've had where we had test A, which became flaky. But this time, when it failed, we'll retry that test on the spot until a configurable amount of times. And this is something you have to tune and play with. And, depending on your comfort level and your resources, you have to configure that. But for example, if this test fails, let's configure it to run, two more times until maybe we can get it to pass. And this test is still flaky. The flake has not been resolved, but a retries allows us to at least keep a healthy CI pipeline going. And that can sometimes be very important, in the real world, let's say. And the way you can use test retries in Cypress is that you can just simply configure it in your Cypress config, and there's various ways to do that. On the right-hand side, you can just disable test retries by setting it to 0, or you can actually configure how often do you want tests to be retried based on the particular mode you're running it in. So you can have a different amount of test retries happen in the interactive open mode of Cypress, or you can configure test retries when Cypress is headless. And you can also do this on a test-by-test configuration level as well, which can sometimes be useful if you just want to apply this to one block of tests or one particular test. Test retries helps to keep your CI pipeline running smoothly, but it has another side benefit, which is it allows you to detect flake. And this is important because sometimes when people look at test retries as a feature, they're like, well, you're just kind of brushing the problem underneath the rug. And that's not the case. We're trying to be pragmatic to keep our pipeline green, but also because it allows us to detect flake, then we know which tests are flaky, and then we can go after them. And so if you use the Cypress dashboard, for example, we can actually mark, for a given test run, how many flaky tests did that particular test run have while it was running in CI. And we can also provide, better, analytics around that as well to kind of give you a bird's eye view of the state of flake within your test suite. So I covered a lot of things in a very fast amount of time. We've barely scratched the surface of the topic, and I hope to talk about it more in future sessions. With all that said, thank you so much, and the team here at Cypress loves Nuxt, and congratulations on Nuxt 3 as well. Thank you so much.